The DVB webinar on HDR Dynamic Mapping. As Owen said, there are 3 parts in this webinar. First, I'm going to present a little bit the context of high dynamic range in DVB standards. Then I'll give over to Jason to explain what HDR Dynamic Mapping actually is. And then the third part will be a bit more going into the technical details of what we standardized in the DVB standards regarding HDR dynamic mapping. So let's start, sorry. Okay, so let's start with the first part, which is Ultra HD and high dynamic range in DVB standards, which is a little bit to set the context of this topic. So in TM-AVC, our main standard is TS101154. It's called Specification for the Use of Video and Audio Coding in Broadcast and Broadband Applications. What is it? Basically, it's a DVB codec toolbox. It lists the codecs and formats, audio-video codecs and formats, of course, supported in DVB on all DVB delivery paths. So it means terrestrial, satellite, cable, but also managed IPTV and OTT, such as DVB-, which is really the DVB profile of the MPEG- standard. So this is really an application standard that just lists all these codecs and formats on top of this delivery path. So we have a DVB profile for each codec and, of course, guidelines for encoding, decoding, and signaling. This standard has been around for quite some time now. The only thing we're really interested in here are the last few updates, especially the one from 2017, which added UHD Phase 2 and therefore high dynamic range as a supported format for DVB standards. Especially what this whole webinar is about is the very last update we've made last year, which is adding HDR dynamic mapping on top of the existing UHD Phase 2 HDR standards. So just to set the context, what we had already in TS101154, what we had standardized for UHD Phase 2 were 2 high dynamic range systems, the PQ10, which is really an electro-optical transfer function, so it standardizes the transfer function on the receiving side, and this is standardized in the specification ITUR BT2100. It's called the PQ system, and its main feature is not backwards compatible to standard dynamic range displays. The second HDR systems we have in UHD Phase 2 is HLG, which standardize more the transfer function at the production side and which offers some kind of compatibility to standard dynamic range displays. Now, I'm just explaining this to set the context. In the context of dynamic metadata, this is something that is optional and added on top of the PQ system. So why am I mentioning the HLG system? Just to set the context and to explain actually that dynamic metadata is not intended, at least in DVB, for the HLG system. This is really something that's intended for PQ. Now, you may have heard from static metadata. We had static metadata already in TS101154. We had standardized it together with UHD Phase 2 for the PQ system. This static metadata basically gives you information about the display you've graded the content on, or about the whole content. It's not really practical to adapt the characteristics of the signal on a frame-by-frame basis. This is why it's called static metadata. What what we have done with the HDR dynamic mapping work item is adding some dynamic metadata on top of that on a frame-by-frame basis, which Jason is going to explain a bit more about. In terms of DVB standards, you should also be aware of two other standards that both reference TS 101.154, EN 300.468, also called DVB SI for service information. Bit streams that carry this dynamic metadata in the MPEG-2 the other one is TS 103.285, which is the MPEG dash profile for DVB, what we usually call within DVB the DVB dash. That has also been adapted to enable signaling of bit streams that use this dynamic metadata. So you should be aware of this of these two additional standards to use together with TS 101.154. And of course, which one you take depends very much on your application. If you do some more traditional broadcasting based on the MPEG-2 transport stream, you want to look at the DVB-SI. Otherwise, if you're doing more MPEG-dash kind of delivery, you will want to look at the DVB-dash specification. Now going more in detail into what we've done for the HDR dynamic mapping. In terms of standardization, as I was saying on the first slide, we had this HDR specification already in TS 101.154 in 2017. DVB discussed for a long time if dynamic mapping should be added on top of this, because this is optional feature on top of PQ10. DVB finally decided there was some value to having this standardized within DVB. So in 2018, commercial requirements were prepared from the commercial side that Jason's going to talk a bit more about. And last year, we updated our specification TS 101.154 to support this HDR dynamic mapping. We're not completely finished with this whole activity. We're now in an activity called V&V for verification validation. The goal is basically to support market introduction by providing test bit streams, including this dynamic metadata. Test bit streams that are both transport streams and DVB dash. Now, I would like to be able to give you a nice URL where you can find these test bit streams. That would be very helpful for you, I guess. But the problem is we're not finished with this activity. It's still ongoing, so I can't provide you the test bit streams yet. But as soon as they are available, this will be announced on the DVB website, of course. So this concludes the first part of the of this webinar. Is there any questions on this part already?
Thank you, Virginie. I don't see any questions coming in yet, which means everything must be totally clear to our attendees, which is great news. We can, I think, continue and hand over to Jason for the next part. Are you there, Jason?
Yes, I am. Good afternoon,
Great.
Owen. Good afternoon, everybody.
And just a reminder again that you can use the Q&A interface, and we'll take a short break before Jason hands back over to Virginie in a moment.
Thanks, Virginie, for a great introduction. I think that's really helpful to set the context. So what I'm going to talk about in the next few minutes is try and answer the question: well, what is HDR dynamic mapping, and why is it that it's valuable to have the capability of delivering DVB services with HDR dynamic mapping? So as Virginie outlined, the first step in any of our work in DVB to set new specifications is to look at what the commercial requirements of the industry are. And on this slide, we've put an excerpt from the commercial requirements, which I think actually does a really nice job of summarizing what we're talking about here with HDR dynamic mapping. And I'll let you look back and read this at your leisure. But the important things I pick out of this paragraph here is that we're talking about a solution that enables the very high fidelity HDR video signal to be adapted in the consumer receiver to suit the capabilities of individual displays. So it's accepting that the consumer display will not typically have the extraordinary capabilities in terms of dimensions like a range of luminance, range of color. The consumer display will not have the same range of capabilities as a professional mastering display. But the idea of HDR dynamic mapping is that we can enable the display, we can help the display to do a better job of mapping the image to suit the capabilities of that individual display. And through doing that, create images that are closer to what the original intent of the creatives working on the original picture were. Virginie, if you could step forward to the next slide. So once we'd identified what we were talking about, we went on and defined a number of other key commercial requirements, and I've pulled out a few of the key ones here to give you a flavor of the scope of the solution that we asked the technical team in DVB to look at. As Virginie pointed out, although there are two HDR systems specified in DVB, so PQ10 and HLG10, the scope of the dynamic mapping work was purely set to be around PQ10. And that's because there's an alternative mapping characteristic that was already defined within HLG, and it was not viewed to be necessary to specify this mechanism for HLG. So the scope is purely PQ10 images. A very important characteristic, and perhaps the most defining characteristic that influenced the subsequent work, was that we wanted to ensure a situation where services that were delivered using a dynamic mapping solution would remain compatible with either existing or future PQ10 receivers in the marketplace. So that a consumer with an existing PQ10 receiver without the capability to do anything with the dynamic mapping information would still receive the same image as they would have done before the introduction of the system. So the bit streams would be completely backward compatible to existing or future baseline PQ10 receivers. Similarly, from a broadcaster or service provider point of view, a very important commercial requirement was the adoption of these schemes should be optional. It shouldn't be mandatory to include any information for dynamic mapping within the service. It should be at the discretion of the content provider or service operator to include this, rather than something that was mandated by DVB. We anticipated that the technical work might lead to the identification of multiple systems for inclusion in DVB for dynamic mapping, and we set out that if multiple systems were included, that it should be possible to carry multiple different systems within the same bit stream. So you should not have to decide for any particular piece of content to just use one dynamic mapping system. It should be possible to include multiple systems in one bit stream, and they should remain compatible. And I think one key observation that we made whilst we were developing the commercial requirements that I think was a surprise for some of the participants was that although I think these kind of concepts sometimes get associated with premium displays, actually observation was made that the concept of HDR dynamic mapping generally offers more benefit for mainstream displays than high-end displays. And that's because what we're talking about is mapping an image from a set of capabilities of a reference monitor to the capabilities of consumer display. And typically the difference will be bigger when you're mapping from a reference display to a mainstream display than it would be if you're mapping to a high-end consumer display. And so there's more work for the mapping engine to do. And if we can provide some extra help, then it's going to really benefit those mainstream displays. You can move on to the next slide, where you can see a little bit more visually what we're talking about with HDR dynamic mapping. So on the left-hand side there, you see a representation of the range of colors and the range of intensities that a reference display could show us. So it's a 3D volume. We call it a color volume, and it represents the complete range of colors and intensities that a particular display can show us. And if we want to take a piece of content that's been created on a reference display like this and map it for display on a consumer device, we need to remember that there are many different kinds of display out in the market. There are high-end displays, there are mainstream displays, there are LCD displays, there are LED OLED displays, displays using other technologies. And so, so a mapping that works for one kind of display is not necessarily going to lead to optimal display on another device. So let's look at some of the ways that we can approach mapping to these different devices. As Virginie outlined, what was already in the DVB specification previously was a mechanism for doing static mapping. So this is one kind of mapping that might be applied for a whole service or a whole piece of content. Now this can work very well, but it's content dependent, and let me show you in the next few slides why that is. For example, let's take this image here. So let's take this shot of a glacier in the sunshine. So this is an image that has an incredible amount of bright detail. So it's a relatively bright image overall, but we've got some wonderful highlights in the bright areas, but also some amazing detail in the darks. Now, what I would ideally do in mapping this original image to a more limited consumer display is I would map all the pixels in the image down. So I would take some of the brightest parts of the image and move them down, but also some of the darkest bits of the image, and also move those down so I can preserve the dynamic range. If you move to the next slide, please, Virginie, you can see the difference that would make compared with a typical static mapping curve. So on the left-hand side, I have a static curve that which is kind of my universal mapping. And you see that static mapping results in compression of the highlight detail. I've really lost the glint of the sunlight and the real texture in the image. Whereas if I'm able to use dynamic content mapping and change the mapping curve so that I can shift the whole image down, you can see it results in a lot less compression of that highlight detail. In the next slide, let's look at another example. So it may be a little bit difficult to see the image here depending on the computer display you're looking at the webinar in. But what you may be able to see there is an image with a dark image with a couple of dark feathers in it on a bit of rumpled cloth. Now this is a dark image. It's been purposely exposed to overall to be dark and dramatic. And so what I would ideally do with this piece of content is kind of the opposite from the previous image. I want to map the whole image up a little bit. I want to take the darkest tones up a little bit and also the highlights up a little bit as well. So it's all just a little bit easier for me to see. And again, if we move to the next slide, please, Virginie. On the left-hand side, you see what would happen if I applied my normal static container mapping curve here. Really end up with an image that is just too dark for me to really see what is going on here. Whereas in By being able to change the mapping dynamically, I'm able to have an image where I've got far less compression of the dark detail. I can still see the rumples in the cloth. I can see the light glinting on the edges of the feather, and I can still make out some of the textures of the feather. So it's dynamic mapping that enables me to vary the characteristic of the mapping that's applied on a shot-by-shot or frame-by-frame basis in the consumer device, so that I have an image that ultimately better reflects what the original creatives intended. I think, Owen, this would be a good point to perhaps pause and see if there's any more questions.
Thank you, Jason. Indeed, I think everything remains totally as there are no questions coming in. So that's good news. And if Virginie is there, then we will hand back over to her.
Yes.
Virginie. Great.
Of course. So thank you, Jason. Now I'm going to go a little bit into the details of the dynamic mapping solutions that we standardized in our DVB specification. So, first of all, there were 3 different solutions for dynamic mapping on the market. And since all these solutions can actually work together in the sense that you can put them into the same bit stream, and the receiver can then choose which one to use, there didn't seem to be any reason to leave some out or to choose one. Especially since this is really an optional feature on top of what we already have. So in order to enable innovation
Virginie,
yes.
Sorry to interrupt you there. I think your audio just dropped out for a moment. If you could just repeat that.
Okay, sorry. So as I was saying, there were 3 dynamic mapping solutions on the market, and since these solutions can be more than one solution can be put into one elementary stream, DVB didn't see the reason to choose one of them. Since these solutions can work together in the sense that they can all be put into one bit stream, the receiver can then choose which one to use in the end, and in the sense that it's optional features anyway on top of what we already had, there was no need to select any one of them. So in order to enable innovation and competition, all 3 of them were standardized by DVB. The first 2 are SEMPT standards, ST2094-10 and -40. The last one, SL-HDR2, is an ETSI standard. They are all backwards compatible with PQ10. As explained before by Jason, they are all optional in bit streams. And technically, these dynamic mapping information are delivered using the standard user data T35 SEI messages embedded in the video elementary stream. And if you are familiar with video elementary streams, these SEI messages can very easily be removed by a decoder or ignored by a decoder that does not understand them. So technically, it's very easy to just ignore it for a decoder and a display, of course. And that's why multiple HDR dynamic mapping solutions can coexist within the same bit stream. You just have, for one frame, 2 or 3 different SEI messages with different information, and the receiver can really pick the one SEI message it is interested in, or none of them if it does not understand any of them. And the bit stream itself is still the normal PQ10 signal. So TM-AVC evaluations. For TM-AVC, it was of course very important to check that legacy receivers were able to simply ignore the information, and to see the difference between a receiver that would ignore the information, and a receiver that would not ignore it and do something, do some kind of processing on the image based on it. So we evaluated all three solutions, proved that the resulting picture was different in case the receiver used the dynamic mapping data or did not use the dynamic mapping data. Of course, if the receiver used the dynamic mapping data, the quality of the video was slightly better, but at the same time, the basic baseline PQ10 signal still delivered an acceptable picture, which was this backwards compatibility requirements that was very important for us. All three solutions fulfilled this requirement, so TM-AVC was happy with this solution when considering the commercial requirements that we had. So going a bit into the details, the first solution we standardize is ST2094-10. You may also have heard it within the market as named as Dolby Vision. It's also known as Dolby Vision within the market. The metadata in this solution basically describes characteristics of the content, but that's true for all three solutions. In the case of Dolby Vision, the system is based on a parametrically defined tone mapping curve. And the primary elements of that curve are deep shadow, midtones like facial or interior, and the highlight regions. Dolby Vision has been implemented by Dolby, among others, in real-life product. They have shown demonstrations of it many times. This one is a demonstration, for example, at the IBC last year. So there are implementations existing of this technology. The second technology is SL-HDR2, which is also known in the market as Technicolor HDR. In this case, the metadata embeds 5 groups of information, characteristics for the HDR and SDR picture that corresponds to the picture, variables for luminance mapping, color corrections, and optional gamut mapping. These systems can be operated in 2 modes, parameter-based mode and table-based mode. Technicolor HDR has also been implemented. One example of a demonstration was made at DVB World last year. So again, this is something that has been proven to work, that has been finally, the last dynamic mapping solution is ST2094-40, which is also known in the market as HDR10+. Again, this is the information contains a tone mapping curve that preserves details based on a first part of the curve, which is the linear part. Image change, and this part is up to a design point. Above this design point, there's a shapeable Bézier curve that adjusts the tones in any luminance range. Of course, any luminance range above this point. In addition, additional statistics on scene value distribution, that is called percentile information, that allows HDR optimization and the display on a frame basis, and this is very much something that the receiver can decide to use or not, depending on what is implemented in there. Same as for the other two, HDR10+ has been implemented in products. There is here a demonstration at the IFA last year. So this is something that has been proven to work in implementations as well. For more information, you have here the links to the 3 relevant DVB standards that I mentioned at the beginning. First, TS101154, describing the metadata in the elementary stream, then DVB-SI, and finally DVB-. Which is the end of the presentation. Do you have any questions?
Thank you, Virginie. So we did have one question that came in from Francesc, but I think you answered it in the meantime. But then another question there, he asks, isn't Technicolor HDR deprecated? I think that's not the case, but
No, that is not the case.
no is the answer to that question. So unless there are any other questions, I'm very pleased to report that we have had at least 40 attendees in addition to the panelists that we've had on the in addition to the panelists. Virginie, if you could just hop back one slide there, because I think you maybe didn't show the previous slide quite long enough on the screen. And I will make these slides available on the website right away. They will be available for download within a couple of minutes, and we will make the video available then as soon as we've done the necessary processing on. So unless...
Oh, and I see we do have one more question just come in, I think.
yes, there we go. Thanks, Jason. Does a receiver have to support all three formats?
No. That's very simple. No. A receiver does not have to support any of the formats. This is why it's optional. So a receiver can really choose whatever format it decides to support. This is a commercial decision that has nothing to do with the DVB standard.
Great. And I am just going to take this opportunity to, we're showing the links there. I'm going to take the presentation back from you, Virginie, just to show the attendees where physically they can find those three documents on the website. So just a moment, I'm going to be the presenter here, and I'm going to share my screen. Just a moment. So on the DVB website, which I have open here, if you click on notifications, and if for example, my network is just a little bit slow there. There we go. So the library opens up, and the quickest way on our new website to find a specification is just to start typing it. So if you're looking for dash, you start typing dash, you get the dash specification there. If you're looking for DVB SI, you type DVB SI and you have the specification. And if you want the AVC guidelines, you can start typing AVC. And indeed, if you click through there for any of these specifications, you get a little bit more data on the specs, and you can download either the latest published version of the standard or the Blue Book. So with that, just one last check as to whether we have any more questions coming in. Great. And just to say, yeah, Simon is pointing out that we just need to point out which is the most recent version. So in fact, in this case, the most recent version, Virginie, correct me if I'm wrong, is the published version.
That is correct.
That's the standard right now, is the most recent version.
Yes.
Great. We have another question just coming in there. Are there any visual quality-based comparisons that have been done on the three solutions?
Not of the solutions against each other, no. We have compared visually with the PQ10 signal, as I was saying, to prove that the receivers acting on the dynamic metadata were doing something, changing the image, improving it, but we did not compare the different solutions against each other.
Okay, and indeed there's a couple more questions coming in here now. Dynamic metadata are scene-based. How can the encoder look in the future of a live broadcast?
So maybe I could have some input from the proponents here. My understanding is there are different tools that enable the support of that for live broadcasts.
So I can speak to this one.
Yes.
So certainly dynamic metadata can be created in a scene-based fashion. So can be created, for example, during color grading process that's typically used for post-produced content. But there have been demonstrations by several of the proponents of these systems of real-time dynamic metadata generation systems too. So the ability to create metadata algorithmically in real time at or close to the video encoder. So at the end of the end of the chain just prior to broadcast, and to automatically create that metadata in live and in real time, rather than having to rely on metadata that's authored further upstream. So dynamic metadata can still be used in systems that are live in real time.
Okay, I hope that answers Roland's question there. Another question has come in. Will the content be encoded with all three metadata formats or with one of them?
It's the decision of the content provider. That's why it's optional. It's not only optional for the receiver, but it's optional for the bit stream to carry as well. So if a content provider wants to prepare the content with one set of metadata, they can. Two sets of metadata, three sets of metadata, they can as well. This is decision of the content provider.
Great. Thank you for that answer. And I think just to clarify the question that was raised about whether the Blue Book or the standard is the latest version. In each case, we're actually working in the project office on just an improvement to the layout of that specifications page to make that clear in all cases. But to point out that in the case of DVB SI, even though the Blue Book published date is older than the ETSI standard date, the Blue Book is the newest version of the DVB SI standard. There's always an offset there on that particular specification. So with that said, and unless there is anything else coming in now, I don't see anything. I'm going to say thank you to Virginie and to Jason and to everyone who contributed to putting this webinar together. We will have another DVA. Oh, I see one last question coming in under the wire here. Where has that come? I saw a question popping up, but here we go. Are all profiles of all three methods backwards compatible or only some profiles?
All are backwards compatible. PQ10 signal.
All are backwards compatible. Okay, that's clear. And from Miguel, is it possible to deliver various formats simultaneously in the same stream?
Yes.
Yes. Good, simple answer as well. Okay, with that said, I'm going to end it here and say thank you again to everybody, and we will make the video of the webinar available within the next 24 hours. So thank you very much.
Thank you.
Thank you, Owen.
Thank you.
Thank you.
Ouais, mais ça, un appel pour essayer de comprendre un petit peu ce qui